and figure out how to do this. All right, can y'all see that now?
Yep.
Good, okay, let's roll. So we're gonna learn about Nmap, or network mapping. First things first, don't be stupid with this. You have the access to any computer on the internet with this machine. So be safe, be smart, don't do it to a bank, the FBI, etc., or we will make fun of you publicly. I think y'all got it. Cool. So what is Nmap? It is a tool used to discover host services on a network. And it relies on packets. We're going to learn about packets. Packets are like little, the words aren't reused in the computing world. A packet is a packet. It makes sense because it is a bunch of data wrapped and is sent to places. That's what you do with real packets. Cool, cool. So why would you use Nmap? So let's say I am in my room and our Wi-Fi is being very, very slow. And I'm saying, maybe it's because our neighbors are stealing our Wi-Fi. I can check with Nmap and see how many machines are on my Wi-Fi, and then deduce whether or not my neighbors are being mean. And as you can also check for vulnerabilities. Obviously, nothing is perfect. You might have an open FTP or SSH port on your computer, and you might not even know it. You're pretty stupid if you do that, but it can't hurt to check. So Nmap has scripts that run on the Lua engine. Lua sucks. I tried to write a script in it, and I gave up and used Python because Python's easier. It's called NSE. So let's actually use it. Okay. So let's first grab our IP, 114. So let's just Nmap myself. I don't have anything open, but why not Nmap myself? So it's not going to happen instantaneously. It's going to go at its own leisurely pace. And what it's doing right now is that it's scanning 1,000 ports, the most commonly used ports, and it will report that nothing is open because I am a very safe person. But I can instead of Nmapping myself, I can check every machine on this Wi-Fi node. And I'm also going to do tack fast because 1,000 can take a long time if I'm scanning everything that exists. There's like 5 things in here that are actually on the internet. I got a printer, my roommate's Xbox, this laptop, my phone. That's kind of it. And it'll take about a minute, maybe or so. So what it's doing is it's going through ports. A port, like I said before, words are not reused. There are no new words. They are reused. Port is a port. What do you do in a real port? You send the ship in, you trade, you do your thing, and then you go out. That's what a port is in a computer. So it went through and it found 3 hosts on my Wi-Fi. This is the router right here. It's got your domain, HTTP, UPnP. So it's going to show the port, the state, and the service. So state is the state of the port. It'll be open, it'll be closed, and it'll also be filtered. Filtered is like a whitelist or a blacklist, right? Right. So this is my printer, I'm pretty sure. I don't know what else would have the word printer as a service. And it's open. You can abuse that port. Printers can be hacked very easily, as we may or may not do sometime this year. Yeah, so instead of Nmapping myself, I have a website, which I will then Nmap. It has a lot more fun ports that we can check out. And it will take a hot second. As there it goes, 8 seconds. So we have a lot more ports here, a lot more stuff we can look at. FTP, secure shell, HTTP. Identification, that is closed. That identification, I think, is I think it's whenever you're SSH'd into the machine, it tells you what you are, I think. HTTP secure, Nessus MySQL. Yeah, more stuff. That's cool and all. But let's say we want to figure out more stuff. What else is on this machine that I have just nmapped? Also, I have typed in the DNS and it has the IP. So I want to nmap it again, but I want to do it aggressively. I think it's capitalized A. I have notes here. Yeah, capitalize A. It'll show me a lot more stuff, but obviously that'll take longer. So we're going to do verbose. So verbose means while it's going through checking ports and services, it'll report back. It'll send packets back and say, hey, this is what I'm doing. This is what I figured out. And so we're going to let that run. And here it goes, get us pre-scan, and it's going to discover all the ports. And it's going to say, hey, we found open stuff over here and here. So we finished our port scan. Now we're going to do our services scan. And aggressive, it's called aggressive because it means more stuff. That's basically it. It's not like the actual term aggressive. It's going to find the operating system. It's going to figure out more info on the ports. It'll have, if you're an SSH port, it'll show the certificate, if it has it, the SSL certificate, assuming it has it. What else? Public and private key, not private keys. It'll have public keys. It'll show that hash. And this, once again, will take about a minute. It was a lot shorter when I was testing earlier. But I guess while that's going, you can open a new window and try something else. So if you're in the cybersecurity field and you do cyber stuff, you're going to do a lot of waiting. So while you're waiting, you can do other stuff. However, when your stuff that you're waiting on is done, you're going to want to export it to files, and then you can parse those files. So that's why there are export options. There's TechOX, that's export to XML file. That's very useful if you're scanning a monumental amount of machines and IPs, because that's what you may end up doing. You may be scanning thousands upon thousands of machines, and by the time that's done, you don't have the time to scroll through your terminal and say, well, this was open, this was closed. It'd be easier to just, I can use another machine that I have. I think it's 74, 91, 120, 24. OX output XML. So it's going to nmap my virtual private machine. It's going to show the output here, but we can vim output.xml. And it's XML. It's a lot of crap, but it shows basically what you did here. And it's going to say, hey, this is the verbose level debugging host, et cetera, what all happened. And that's cool. But if you're going to export in an XML format, might as well try and parse it. That is still going. So we're going to segue this into the Heartbleed somehow. So I know 3 external hosts, I think. So we're gonna tack fast that. So 6494238663. And you can also scan multiple things. Finally, that's finished. 74, 91, 120, 24, and my website. Output to put.xml. So that's going to go. It's going to take longer because it's 3 things. Just kidding. It was instantaneous. So back to, let's jump over here to what I was doing earlier. So this is the aggressive scan of all of my jazz over on my website. So here's TCP. It has the version and all that stuff. It's going to have your public key, the RSA, how many bits are in it, the signature algorithm, a lot of stuff you may want to figure out if you're a bad guy. You never know. So this is the HTTP. So if I went to the public folder and I happened to type ls, these are the first 10 things that would come up. my images. So it supported methods, get post options head. This is closed, so it didn't show anything. This was open. What else did it find? It's Apache server. Once again, RSA encryption, 1024. Here's MySQL, the version of MySQL, all that stuff. I could have sworn it would have shown me the operating system. It did before, but it's Linux. That's cool. Jumping back, it's a lot of stuff, and so it's a lot of stuff you might want to output that if you're scanning a lot of things. So back to what I was doing earlier, I was scanning 3 different IPs, and I was exporting all of that data into the output, or into an output file. So let's say, and pretend that was 4,000 IPs, and I wanted to parse that for every instance of an open FTP port. I wrote a script for this. It is what's the FTP.py, send it to output.xml. It's going to run through all of that, and it's going to say, hey, this IP has an open FTP port. This one does too, and this one. That really beats the hell out of scrolling through several hundred or thousands of lines of garbage. So we're going to segue from here into the Heartbleed. So the Heartbleed vulnerability came out in 2014, and it was also patched in 2014. Well, it was discovered in 2014. So the Heartbleed vulnerability, here's a meme I found. Filter reports, basically whitelist, blacklist. So the Heartbleed is basically, you're in an FTP server, right? And when you're connected to an FTP server, let's just say every minute, you're going to send a packet, say, hey, are you still there? And the server's going to say, yeah, I'm still here. What you're really doing is saying, hey, if you're there, repeat this message back after me. And so you send a 6-worded message to the FTP server, and it will send a 6-worded message back. So there was an issue here where you could allocate 20 kilobytes worth of data, but only ask for 10 kilobytes in a repeat message. So the 10 extra kilobytes that were allocated were also sent back. And whenever that happens, the allocated memory could have been literally anything. If you look closely, you can kind of see connection using key, stuff like that. A lot of jazz that's still in there that was sent back to you completely not on purpose. It was actually traced back to a single line of code. It was a mem copy or a mem set. Basically, it was allocation that was not zeroed out and then sent back. That was how they fixed it. But it goes to show that every line of code could either make or break you. So let's say if I was an evil person and I wanted to exploit the Heartbleed, I could scan literally the entire internet, which exists. There is TechIR, which is Nmap a random host on the internet. So let's try that. I'm going to attack fast it just in case. IR, we're going to do 100 random people on the internet. We're going to fast it and output to output.xml. That could take a while. So as I was saying, you could figure out a bunch of different IPs that were on the other terminal and say, hey, I'm going to try and Heartbleed these. I don't have to be theoretically connected to the server to just say, hey, repeat back to me. Cool, cool. And it could send back data. It could send back you passwords, private keys, etc. And obviously that was bad. So that could take a while. So I'm going to open up a new terminal and I'm going to go over trace routing. Trace routing is very useful because whenever you're connected to the internet, you know, ping, MS, how long it takes to get from you to the server you're playing on, your Call of Duty server. It's not a direct line. You are bouncing from port to host, port host, port host, port host, all the way to where you're playing. And then it's going to come all the way back. It's most likely through the same route it took to get there. So my host is located in Seattle, and we're going to trace route it. I need to do that as root. And that looks like that finished back there. So we're going to trace my route that I take as I go whenever I connect to my server, my website. And it will bounce from my computer to my router through the world of the internet all the way to Seattle somehow, which decides to take longer whenever I'm doing it in a presentation manner. Awesome, that's taken a while. So back to here. So we scanned 100 random IP addresses and it found 5 open hosts. So these are random people on the internet. These could be the FBI, they could be grandma, you never know. It's probably not the FBI, but it could be. So it's a bunch of random ports you've discovered. Most 100 commonly used ports. None of them have open FTP, which is cool, but that's not a big deal. Just goes to show that you're never truly, nothing's ever truly private. You can be nmapped at any time, theoretically. So that finished. So let's start from 1. This is my router, and then it goes to some random IP addresses, and it bounces all the way around, has our hop count, all the way to Georgia, AT&T Internet. Awesome. So if I had a map in front of me and I was drawing my path to Seattle, I would end up going through Georgia, which doesn't make sense, but it does because that's how the internet works. So from Georgia, it goes to Atlanta. It's probably Iowa. Who knows? These are probably cities. St. Louis. That's probably Seattle. Yep. All the way to Seattle, which took 88.85 milliseconds. So I could ping it, and it would be relatively the same time. Yeah. 88 milliseconds. So yeah, that's a trace route. What else? Oh yeah, mass scan. So mass scan is like Nmap, but it's faster because you are scanning massively. So I hate mass scan, but it was on the presentation, so I have to go over it. So after running as root, it doesn't take domain names. It has to use an IP. So I'm just going to use this one. Ports, we're going to do 20, I don't know, 1 to 100. And sudo it. Mass scan is like Nmap, but it's built for larger scans. If I were to, say, scan a million bajillion machines, I would want to use mass scan because it is faster. However, because it's faster, it is less reliable. You're not going to have as accurate results because you are going at Mach speed, which is kind of why I prefer Nmap because it's reliable. It's not going to mess up. It's stealth scan. The syntax is pretty similar to Nmap's. You can also export. The switches are almost the exact same. So yeah, it's done its stuff. Open port from 0 to 100, or 1 to 100. 21, 22, and it'll do that.
Where'd they go?
I'm in a meeting, bro.
I'm so sorry. Is it 8? Oh, there's a meeting tonight.
Yeah. All right, you're in. So we have a new person joining the meeting. Yeah, that's kind of it for network mapping and the Heartbleed vulnerability. This also, I should mention, this is the start of our new sprint. We're doing enumeration. We started last week, but no one came last week because of exams, which is understandable. Enumeration, you guys know what that means. We are looking through things, expanding and seeing, etc. Yeah. Any questions, comments, or concerns?
Thanks, lawtech_ace codes.
Of course, rs041 at lawtech.edu. 041.
I was just looking at that.
If only we knew your real names.
What was that?
I said, if only we knew y'all's real names.
Yeah, I'm John. My name is John. There I am, John Muscagni.
I'm Gavin.
That's Gavin behind me. Where was I?
How many people are in the meeting right now?
7, 8.
7 or 8.
Yeah. So, if there are no comments, questions, concerns, thank you all for coming. This has been Nmap by John.
Thank you, John.